So in this question, the safari question, you've got a team of naturalists. They're headed out towards a station that's 6.4 kilometers away. So you can see on the diagram, we've got the research station is here. And they're starting over here. Okay, so they're doing okay, except after 2 kilometers, they realize they're actually going the wrong direction. They're going 30 degrees north of east instead of 42 degrees north of east. So they course correct. So the red arrow is the thing we're trying to find. And you can see that the dark blue arrow plus the red arrow should equal 6.4 kilometers, 42 degrees north of east. So how do we find this information out? Well, over here, what I've drawn over here is sort of like a reframing of the question, where instead of saying, I mean, if you think about it, if the blue vector is A, the red vector is B, and the green vector is C, we can say that A plus B equals C, right? A plus B equals C. Vectors. This is like, we have to think of it as a triangle. But then another way we could say this is that vector C equals vector, well, let's put it like this. We can say vector C minus vector A is equal to vector B. And what we want is vector B. So the best way to solve this problem is by doing this vector. We have to find C minus A. And another way of saying C minus A is C plus negative of A equals B. So what I did here with the light blue arrow is so this green vector is still C, right? But now this light blue vector is the exact same vector as the dark blue one, but I've just reversed it. So it's pointing in the opposite direction. Exact same magnitude, opposite direction. And then what we have over here is it equals B, the thing we're looking for. So I can stick that, right in there. And that should, see it works out exactly. And this is the vector B that we're looking for. All right, so the way we'll do this is the same way. This is a pretty somewhat complicated triangle to solve, but we can do this relatively straightforwardly by using components. So what we're going to do is find the components of C, find the components of A, and either you can think of it as subtract the components of A or add the components of negative A. I mean, whichever way makes more sense to you. I think what I'll do is just this first one where it's like I will find the components of C, find the components of A, and then subtract them. So we're going to set this up in a similar way we did before, where we're going to have our X and our Y. So there's my X component, my Y component, and I'll draw this little table here, and we'll start to solve. Let's move this over a little bit. Oops. And then we'll move this over here. Okay, so the first vector we're going to look at is C. So vector C has, and I can draw these each one out individually so we can kind of look at them with a little more clarity. So there's the 6.4 kilometers, and then the axis is here, my north, south, east, west, and this angle here is 42 degrees. It says 42 degrees north of east. I think that's what it says, right? North of east, 42 degrees. So that's this triangle. So we can break this up into its horizontal and its vertical components. So horizontal and vertical components, right? And then we can just solve that triangle. So let's just do it. C, the X component is just going to be 6.4 cosine of 42 degrees. Let's solve it out as we go. So we have numbers, 6.4 times cosine of 42. That gives me 4.756 kilometers. And then the Y component is just going to be 6.4 sine of 42. So 6.4 sine of 42, 4.282 4.282 kilometers. Okay, so that's the first one. Then we got to find the components of vector A, and vector A looks like this. So that's vector A, and it's 2 kilometers. And this angle here is 30 degrees. And again, we've got, excuse me, we've got the horizontal and the vertical components. So similar way we're going to solve this. For vector A, we're going to say it's equal to 2 cosine of 30 and then 2 sine of 30, right? So putting those numbers in, 1.7320, 732, let's just, oops, leave it at that, 732, and then 2 times sine of 30 equals, well, it's just 1. I hope I got those numbers right. Sine of 30 degrees, yeah, 2 sine 30 is just 1 kilometer. Oops. So 2 sine 30 is just equal to 1 kilometer. Okay, and what we said was what we wanted to do was subtract. It's C minus A will give us our answer. So C minus A will give us the answer. That means we can take the x component of C, subtract the x component of A, and we get that. So so it's 4.756 minus 1.732. Oops, 1.756 minus, sorry, 4.756 minus 1.732, we get 3.024 kilometers. And then for the y component, 4.282 minus 1 is just, I could have done that, 3.282 kilometers. Okay, so now we have our x and our y component of the resultant that we're looking for, the red vector. So that's B, right? This is what B is. This equals B. So if I've got B here, I see that the x and y components are x and y. The y component is 3.282 kilometers. The x component is 3.024 kilometers, and then we can find theta. So now the same method we used before, we're going to use Pythagoras, and we're going to use tan inverse. So for the magnitude of B, it equals the square root of 3.282 squared plus 3.084 squared, which equals 0.84 squared, and the square root of that is 4.5 kilometers. And then theta is going to equal tan inverse of the opposite, which is 3.282 divided by 3.024. And then we get theta equals 3.024 tan, oops, answer 47 degrees. 47 degrees. So then in terms of putting in our answer, we get, let's see, we can see that it is 4 point. So like the magnitude is going to be this is the one you get from doing Pythagoras. And then this is the one you get by doing tan inverse of theta. Okay, so this is the best way when you've got these complicated triangles, is just framing it in a way that makes sense and looking, I mean, I think it is, rather than doing the negative A, I do think this method of solving it C minus A and just knowing that basically you're taking the subtraction of those two numbers to get the answer.